Hi, today we're looking at section 2.4, which is angle properties in polygons. So in the last section, we dealt with the interior angles of a triangle adding to 180 degrees. Today, we're looking at the interior angles of any polygon. So essentially for any polygon, we can determine the sum of angles by breaking it into triangles, where essentially each side of our polygon is the base of the triangle, and the triangles all meet in the center. Okay, so I've broken this square into 4 triangles. Now, from what we learned in the last section, we know the interior angles of each of these triangles adds up to 180 degrees. So for a total interior angle for this, we have 180 plus 180 plus 180 plus 180. However, if I just do that counts all these central angles, but we don't use those central angles. Now, because these form a full circle, that is 360. So we have to subtract that from here. So 180 plus 180 plus 180 plus 180 minus 360 gives us 360 degrees. Now we'll do the same thing with this pentagon. So like I said, we'll create triangles starting from the center. So essentially we see that we've got 180 degrees here, 180 degrees here, 180 degrees here, 180 degrees here. And then we still have that center part of 360 degrees. So we have 5 triangles. So we have 180 degrees plus 180 degrees plus 180 degrees plus 180 degrees plus 180 degrees minus that center part, so 360. So our total angles in this is equal to 540 degrees. So our interior angles for this add up to 540 degrees. Now, if we look at more shapes, we can come up with some patterns. So triangles have 3 sides. Quadrilaterals, which include squares, would be 4. Pentagons, which we just dealt with, are 5. Hexagon has 6. Heptagon has 7. And octagons have 8. Now, triangles, we typically don't break into other triangles, so we'd have essentially 1. And we know our sum of angles in a triangle is equal to 180s. Quadrilaterals, so squares and rectangles, we broke it into 4 triangles and we had an angle of 360 degrees. Our pentagon, we broke into 5 triangles and we had 540 degrees. Now, if we were to expand these the same way, what you'll find is essentially the number of triangles we can break it into is the exact same value of our number of sides, because essentially every single triangle had a base that was one of the sides of our original polygon. So this will have 6 sides, 7 sides, 8 sides. Now, each time we're adding another triangle, that's adding another 180 degrees. So the difference between each of these is 180 degrees, which you will have noticed from this pattern here. So hexagons have 720 degrees. Heptagons have 900 degrees. And octagons 1080 degrees. So what we want to do now is prove a sum of interior angles is given by 180 times n minus 2, where n is our number of sides. Okay, so if we go back a couple pages, we can see essentially we're adding 180 as many times as we have triangles, which is as many times as we have sides for both of these. So we can easily say that we have 180 times n. So 180 times our number of sides. Now we were subtracting 360 in the center for both of these because we weren't using those angles. So they both had subtract 360. So we need to include that in this formula. Now we can factor a value out of these. So 180 can be divided by 180, so can 360. So we'll factor that out. So it gives us 180 times n minus 2.